Okay, thanks Jason. Thanks for the opportunity to speak today. I want to tell you about our research on the effects of sheep and cow milk and yoghurt drinks on gastrointestinal transit in a rat model. Assume it's the right-hand one? Yes. Lovely. Okay, so as we've heard today, there's differences in protein composition and protein content between sheep milk and cow milk. Something we're particularly interested in is the effects of fermentation, primarily because this can add value to what is otherwise a raw product, and that's a really beneficial thing to do. Also the health benefits, and so if we can have health benefits ascribed to this, then that can increase the value of the final product. So in many countries in the world, fermented food is sought after for its apparent improved digestion and health benefits. This is sort of already believed to be the case because people have found that to be so. So this is largely attributed to the beneficial bacteria that are present in fermented foods from the fermentation cultures. And also it can be attributed to the bioactive peptides that are released from the proteins during fermentation is another source. Of course, there's other things in milk like the lipids, but today this is what we're going to be focusing on. So the aim of this work was to compare the effect of sheep and cow milk on gastrointestinal transit and to look at how this is affected by fermentation. Are there species differences in how this possible effects might occur? So our hypothesis is that sheep milk will produce different bioactive peptides from cow milk when fermented and thus affect gastrointestinal transit differently. So we fed sheep milk and cow milk and sheep yogurt and cow yogurt to rats and monitored movement of solid contents through the GI tract. So we did this using methods that approximate what's used in humans to measure gastrointestinal transit, so that would have relevance. So we fed the drinks to the rats for 2 weeks, and we monitored movement of the beads from the stomach to the large intestine over 12 hours by X-ray. There were 12 rats per group. They were fed a dairy-free diet. That diet was one designed to keep transit a little bit slower, on the slow side of things, just so we could see if there were any increases, because one of the major effects people are looking to overcome with fermented foods is constipation, so we wanted to be able to see an increase if it was there. So the milks we used were reconstituted milk powder. When we made it into yogurt, we used a commercial starter culture, and then this was reconstituted, made into powder and reconstituted just prior to use. Okay, and the drinks were 3% protein, and they were supplied in the drinking water. So that was the only form of drink available to the animals, which they seemed to rather like. So the method that we use is a method that we've adapted for rats to measure gastrointestinal transit. So 6 beads are delivered to the stomach, and then we monitor their movement over 12 hours. 4 hours, they're expected to have left the stomach and be in the proximal small intestine. They get a scoring for how far each bead has moved. So there are 6 beads given to the animal, and each bead gets a score. So if it gets into the proximal, it has to get out of the stomach to get a score. First it gets a 1 if it gets to the proximal small intestine, a 2 if it gets to the distal small intestine, a 3 to the cecum, which is the start of the large intestine, and then if it winds its way through the spaghetti of the intestine and gets up and around and back down the colon, number 4, it gets 4 points, and then 5 if it gets to the rectum, and 6 if it's expelled. So you can imagine if all the rats stay in the stomach, 0 score. If they all expel, score of 36. So we'll come back to that a little bit. Right. Okay, so actually, just before I go on, I should say these 3 different measures we used. One was have the beads exited the stomach emptying. Next one is how far through the GI tract did they get. And the next one we honed in on the large intestine, so we could take a closer look at that. So firstly, stomach emptying. What percentage of beads left the stomach? So here's the data, and what we found was that here we've got at 4 hours, 9 hours and 12 hours, percent of beads that left the stomach, and we've got the different colours depicting the different drinks. The only ones we saw a difference between at 4 hours was the cow yogurt and the sheep yogurt. So the sheep yogurt made the beads move a bit faster. So just to make the point, we're not looking at how quickly the milks moved, we're looking at how quickly they made the solid beads move. So they're affecting the muscles of the GI tract to do this, to create these differences. So then at 9 hours, what we could see that there was a fermentation difference with the cow milk. The cow milk, when it's fermented, did make things move a bit more quickly out of the stomach at 9 hours. So stomach emptying was more rapid for sheep yogurt than cow yogurt, and cow yogurt was able to overcome the slower gastric emptying seen for milk at the 9 hour point. We then moved on and looked at how things moved through the GI tract. And what we see here is, this is our score system, just showing you what it looks like here. And so at 4 hours, you can see that most of the beads should be in the small intestine. This is an example of how this works. So then by 9 hours, most beads are they've moved through to near the cecum. And then by 12 hours, you expect them to be in the cecum or further along into the large intestine. And this is how the scoring system normally works. At 4 hours, you've got on average 4 of your beads out, and then by 9 hours, most beads are around the cecum, and by 12 hours, most are in the colon. So this is a method that we developed and published. So now the data for transit. What we saw was that indeed when we look at what happens at 4 hours, we see the same as what we did when we measured stomach emptying, that the sheep yogurt's beads are moving faster than the cow yogurt. So it was significantly faster. And then we saw at 9 hours in the small intestine, there really wasn't much difference among treatments, but what we do find when we look further along at 12 hours, by the time things are in the colon, interestingly, there was no effect of fermentation. The cow milk and the cow yogurt were not different. The sheep milk and the sheep yogurt were not different. Where we saw the effect was between the milks. So that was really interesting, that the sheep milk makes transit happen more quickly to the colon than the cow milk. So that's an 18% difference. So we then wanted to look a bit more closely at what's happening in the large intestine, since that's where the major effect was. So we recalibrated, made our 0 point the cecum, start of the large intestine, and we said at 9 hours how many beads are in the cecum. Then we looked again at 12 hours and said how many of those beads have moved further through into the large intestine. And so when we looked at that, this is the data we saw. So this is number of beads, along here's the types of milk. So this is between 9 hours and 12 hours. So we can see that for the cow milk and cow yogurt, there's no difference. Sheep milk and sheep yogurt, no difference. But what we do see is a difference between the cow milk and the sheep milk, and the cow yogurt and the sheep yogurt. So what we're seeing is a bigger species difference than an effect of fermentation. So that's sort of the major results that we saw. So it is a significant effect, over twofold faster. So this suggests that the sheep milk might make slow transit a bit faster. On the other hand, if that's not what you're looking for, if a consumer's wanting something to slow transit, they might choose the cow milk instead. So that's how that's looking. So what we're also interested in is why is this the case? We're inferring that there may be peptides being released differently as these get digested. Obviously, we're not looking at a fermentation effect in this case, but in some of the earlier data for stomach emptying, there was a cow milk fermentation effect. And in one instance, there was a difference between the yogurts. So we want to know how the peptides that are released might be important. And so the next part of the work we're doing is looking more closely at that. And so we're employing methods to look at this, which is mass spec. We've heard a bit about that earlier on. And we get the peptides and we identify them and run them against cow and sheep protein databases that already exist. And we identify what the peptides are. And if we already know what they are and what sort of properties they might have, then we might be able to figure out what the difference is based on existing knowledge, or we might be talking about new peptides. So when we do this, we start with our samples, and we put them through the machine that Heike told us about, then we run them against databases. So what we might expect to find would be peptides that are known to be modulators, peptides that can bind to the receptors on the nerves and muscles of the colon and can alter gastrointestinal motility. So some of these are already known, so we may well find some of these. So this is what the sort of information we get back. This tells us that there are differences in the number of peptides for cow milk compared with what you see in sheep milk, and that when they're fermented, you get an additional release of peptides. So in the case of sheep milk, there's 51 new peptides. In the case of cow milk, there's 35 new peptides. So we're going to be sort of comparing and contrasting all of these as we try to figure out what might be underlying the differences we're seeing physiologically. Okay, so many of the peptides that we have found to be different map to casein proteins for cow, but less so for sheep. And so we know that some casein proteins for cow affect neuromuscular activity, and so we're going to be looking more closely at these in the next lot of analysis that we do. Okay, so in conclusion, the faster colonic transit for sheep milk compared with cow milk indicates that this difference is not due to fermentation, but reveals species differences between the milks on colonic transit. And the sheep milk might therefore act to sort of wake up a sluggish gut in healthy people. The fermentation advantage was seen for the cow yogurt, and this was for improving stomach emptying a little bit. And what we did find for the sheep yogurt compared to the cow yogurt was that it improved both stomach emptying and colonic transit, making them a little bit quicker. So yeah, thank you.
We've got 3 minutes and 20 seconds for questions. I think we should maybe let the event centre know that there's been a lot of sheep product consumed today, and maybe we have some more toilet breaks tomorrow.
There's no rest here.
No. We should look for human trials. We could all be in trial.
Okay, so I was just wondering if you have considered the possibility that it could be something to do with the fat rather than the protein that's influencing the GI transit time?
That's possible. Would anyone else like to comment?
No, skim milk powder.
Okay, yes, skim milk powder, so it's a low probability of that.
So the question is why we're using skim milk? Is this consistency or?
Yeah, partly, and also for the purposes of this study, we're only just interested in the effect of proteins and bioactive peptides.
Right. Okay. Yep.
I guess it depends on what sort of products might be reaching the market, and I guess we were expecting that they maybe wouldn't be in a fresh state, that maybe they would have been dried down and reconstituted.
So why then? Oh, sorry. That's why I don't use one of these. Why then, given that essentially in sheep milk that there are more good bacteria than bad bacteria, why pasteurize it, or what's the different effects when it's pasteurized or fermented rather than in its natural state coming out the other end? Can you understand that sort of thing?
Yeah, and it's the focus of another research project is looking more closely at that. Certainly, the naturally occurring bacteria are probably very helpful and important. In this case, because we wanted to study what was happening with the proteins, one of the reasons for sort of drying things down was to actually get rid of the bacteria that had been used as the culture, so that we could just concentrate on the proteins and peptides, because that was the focus of this study. But certainly those other things are probably very important and would confer a point of difference, point of differentiation based on the farm that milk came from. So that will be a really very good thing to understand much better.
If there's no more questions, we'll wrap that session up and introduce the next speaker.
Thanks very much. Cheers.